So the right now, we come back and that is discussing about another very important topic that is concepts of space. Right. So as of the last one, we have finished up discussing the concept of straight lines or the equation of straight lines. Right. Following the discussion of equation of straight lines, we also discussed about how to find out the angle of straight lines, and along with that, out that to find out for mirror image any particular point of respect to the straight line assembly. So all those particular questions we have finished up discussing them on previous, right? So I took the previous discussion in one of you. So if you haven't watched the previous session, please go back, please playlist and conclude the previous session. Okay. Because without learning about the previous topics, you cannot directly come and watch this particular session. Okay. So in this class, we are going to do another very important trick is going to be to find out the space system. Okay. So let's start. Alright. So let's see that what we actually mean by stimuli, right? So let me start by writing down this space. That is, we're going to start with shortest, shortest distance, shortest distance between two states. Okay. So today we'll be discussing about which is the state line. Okay. So how do we find out this particular system in two state line? Let's try to analyze and see in this book. So first and foremost thing that what you have already studied are two-dimensional geometry that when you have a 2D line, when you have a 2D line, there are two cases. Either the lines are intersecting each other or lines with parallel dimension. Right? So these are the two cases that you must have studied or in a two-dimensional geometry. However, it's very important to note that it might happen even quickly and the lines are not intersecting, not their parallel. Like, for example, if I have some lines like this, which are not intersecting, or even they're not parallel to each other, right? You can imagine these lines by the pins from here, something like this. You can from the top, you will see that it is intersecting. It's like intersecting. However, if I just rotate or change the frame of reference you are walking this particular diagram, it will appear that they are not intersect. So these kind of lines are therefore known as skew lines. Okay, so today or skew lines. Okay, so this kind of lines are skew lines. So in our today's discussion, this particular lecture, we'll be discussing with how to find out the shortest distance between skew lines. Because in case of intersecting line, parallel lines, the distance is going to be the same. However, in skew lines, there are two certain points on the line that will produce this distance. So that will be the main agenda of this session. Okay. So let us try to develop the theory one by one. Okay. So if we first of all plot these two lines so as to formulate the problem, let us take my first line that is L1. Okay. And let us say this is my first line L2 and this line is two line. Okay. This is L and this is L1 and L2. And let us say I take a point here and I take a point forward. Now you know that the shortest distance now string lines will always occur to the common norm, right? So if I know that the string distance will occur along the norm, then it will be right. But you know, what I have to draw such a line which is perpendicular to both of these statements, one and L2, right? So what I will do, I try to draw a straight line that is perpendicular to L2, P, and perpendicular to L1, Q. And this particular line will be the line of line of shortest distance. This particular line will be the line of shortest distance. Okay, this particular line is the line of shortest. I use this here. Okay, so we obtain the line which is between point P and Q to be the line of the shortest. Right now, let us see that how I can obtain this particular line, and then once I obtain this particular line by using the concept of intersection of two lines, I can find out point P and I can Q to obtain the distance between these 2 points using the shortest, right? What we mean, right? Let us try to formulate the actual form. Let us say these two streamlines extend by the equation as follows. Equation number second line. These are my two equations of line. Then the important thing to note about here is that if we need to take a shortest distance two lines, they have to obtain a line which is perpendicular to each other. So now obtain a line which is perpendicular to lambda. The easiest way to explain my direction vector of that particular line is by doing a cross product. So if this is my let us say and let us say this is my input vector, then in order to obtain this particular vector, let us say I call a vector here, right? One is by the name. Let us say S. Okay. Find out the direction of this vector. This particular thing can be obtained by using the concept of cross product because we have studied that cross product will obtain or generate another vector which is perpendicular to the two individual vectors. This vector is going to be perpendicular to this one and this one. Sorry, this one and this, right? So this can be obtained. So the direction ratio of the vector along which is already directed, this distance directed, is obtained by doing this particular cross product, right? Now, now, how do I need to formulate this problem? Like that's another question. But once I obtain this line along with this distance, the only easiest way or the only thing that you can confirm over here is to find out, let us say, how do I do this problem? Is that let us say I have two lines like this. This is my new A2. Let us say I take up any random point, right? Let us say this is my point Q and my point P. Let us say I take any random because it's not shortest distance, it's only generally right. But the shortest distance will occur along the common normal is perpendicular to each other. Let us say that it occurs at D gas Q gas, right? Because this particular distance equals to this, right? Now I need to find out this distance. What I'm going to do is that distance will be simply this particular distance PQ and doing a projection onto this particular common normal. Okay, it's just by doing a projection onto this common normal. So therefore, this shortest distance can be vectorically written as. So let us say the coordinate of point P when a small p vector and small q vector are the function vector of this P and P y. Then I can obtain this particular system P minus Q will be this particular vector and taking a product or a projection. Projection means I'm taking a dot product between the magnitude of the vector onto which I'm projecting. Right? So if I do that particular transformations, then since I am representing by element, so my this particular value with 2% magnitude of element. plus into vector. And then, and then we know the distance cannot be negative. So we will do the final again. So if we calculate by this particular solution, we will obtain what is the minimum distance, the shortest distance between those two lines. I know this clear for right. This is what clear in this formulation clear for the right check. Simple time analysis. Then thing is that it's the distance, this minimum distance, take the projection. Okay. So projection of this PQ vector on this P dash equation. So if I recall from the projection concept we studied in our theory of vector algebra, so I can discuss this part again. A projection of any vector onto of A vector on B vector is simply given out by doing this dot product and dividing with the magnitude of the vector into B times the projection. Okay, so this will generate me the result for the projection of A vector to B vector. Right. So this is something like just projecting taking the component A vector in the direction of B vector. However, the projection is this particular. Right. This we have already studied in our basics in vector algebra when we were discussing about the scalar. I hope this is clear for all of you. I hope this is clear for this part. Question for Cartesian form. Right. So this is the vector form of this surface system. Right. So let us try to write this down in terms of Cartesian. So from this particular result itself, I'm going to declare the result with x, y, and z result. So what I can do is that. So since I have the line in the Cartesian form given as follows, if we show you the equation of line. So equation one and equation two denote the lines in the Cartesian form. So therefore, the this particular persistence, this particular sort of system be given out by doing that expression, which if you do it, you will be definitely getting this particular result. Is divided by the magnitude of this given. It is straightforward. If you just calculate this whole question sum, you will be able to get to the result for the minimum distance between straight line. I hope this is clear for this is the result for the minimum distance between two straight lines or two skew lines in quotation. Okay, so this is how I obtain my result for shortest distance between two skew lines. This is part clear. This part clear. Please let me know in the live chat. Is this part clear? This part is clear. because this particular part is going to be very, very important, especially whenever you are trying to also, right? Now, another very interesting thing here, like from here, you can obtain the SS law, that is, what if the lines are intersecting? So, if the lines are intersecting together, so you have intersecting fields, intersecting bases, you have the base, right? You have the okay, then your minimum distance equals to 0, then your minimum distance equals to 0. So, whenever I have intersecting line, in this case, my minimum distance will be equal to 0. So I just solve this numerator part and equal to 0 for the condition of intersecting lines. I give you two equation of line condition and must be kind of the condition in this line between the two. So you just have to find out the minimum distance between the two lines and equal to 0. That is right. That's the most best way to obtain the final or result for intersecting two lines. I hope this step from I hope this one step from now once you obtain this particular result, also another way to know this function is just by is to just so where here what we have done is that we have just projected find out the distance, right? So just projected two random points onto this pendulum, right? This pendulum. However, I need to know what is the equation of this line. What is the equation of this this line? If I need to know that what is my equation, the equation of the shortest distance, shortest line. So if I need to know the equation of my shortest line or the shortest distance line, what can be easily taken out of this. If I need to find out the this equation of shortest line, if I need to do that, I can change that part, say x minus x a by L. Uh, Let me use some notation. Uh, if alpha over here over, right? X minus alpha minus theta by small b equals to z minus gamma is equals. So this is how we obtain R. The main question is what we define from gamma, right? If KVC components direction ratio will be easily given out by just by doing that cross able to construct of these two vectors of the direction ratio will give me the result ATS, right? So this will give me the result the direction ratio of the shortest distance line. That is my S vector, right? That is my S vector. Now, but if I find out that the top you can one point, how am I going to do that? So this particular question can be done by so if I use for the minimum distance, let's say how will I do it? It's very simple. It's that I will assume a line or I will assume the line is plot and I will solve plot or I will take in point and on some mu. Let's say it's mu. So what I will assume this p q dash or p dash point as my alpha plus a times mu comma beta plus mu times of t comma plus mu times of c. So I will assume this p dash and also I will assume two dash some lambda time like this. So this how will obtain my p dash and q dash. And I will simply solve for that. I will solve for p dash is also lies on this particular line L1. So p dash lies on line L1, so it is the L1. And my q dash lies on lies on lies on the line L2. So from that I will obtain the value of this particular u. And so once I have the value of u and vector, I can easily solve for the point. right? So this is how I can go about solving the points P that students, right? This word came out to I think I know that this came out to the movie try to discuss two topics. And some of them, this one time, who was try to solve some of them in order to understand. So the questions can be put. One, they might ask you, find out the minimum distance between two students, or they might give you a random variable minimum line equation and ask that what is the condition that if we have these two lines that can be a second problem. Also, it can give you the minimum distance of line, and then it might ask you to find out the minimum unknown. That is right. So they have multiple uh, moderation or dilation problems. You can always try to solve problems. I will show you some problems. You have fully day in the Alright. So and also please note that this particular concept is going to be very different, especially for advanced. Okay. So if you look at the previous year on concepts, they make different you will see that distance questions or streamline this kind of event was asked a lot of times. You can see a lot of repetition in this problem. Right? So that makes this kind of this set of problem very very unique. Alright. Now there is one more set of QA that is also being explored in information. Yeah. Let us say I give you this technique. I give you this line. Let us define line L. Okay. And I will give you a point P which is given as alpha kilometer. Now, I want you to find out distance from this line and this point P. Such that along any particular line. So, we give the equation of this line. So, I want you to find out the distance of point P is given as alpha comma beta comma from the line L1 along along the along the line along the line. The distance from L1 is point P, but not directly, not directly perpendicular. Find out the length along this particular. So you can say this particular point, but you take this point Q and this perpendicular drop is so I can solve this problem. So I need to find out the speaking distance. Now I can solve this problem in two ways. One, these two. So what I can do is I can find out this particular angle. I can step on, find out this particular angle, fine. And then I can obtain the distance. Okay, by doing the perpendicular, I can obtain the distance. So now to obtain this distance, that is given out as P upon P of sin theta. So I can obtain this distance by doing this multiplication, right? P upon sin theta will give me my P distance. Also, another way to solve this problem is by we when the equation of and I know the point P. So I will first of all formulate any general point on Q. I will formulate a general point on Q in x y z. Yeah, usually we have one. I will obtain the value of point P in terms of complement, and then I will try to this question on satisfy this particular point P A Q in line 1. So I will satisfy this Q point in line 1, and I will obtain my complement. Once I obtain the value of one point, my Q point will be known to me. And once I know the value of point Q, then I can easily solve it. Then I can easily solve it. It will be step by step after square. Alright, this again is useful. So by doing this particular multiplication, I can come up with a solution of the three distance. The distance is point P on line L1 on the line. So these are the unanswered problems that are very important, especially looking potential. Right? So you will be seeing that this kind of problem is being asked many times. So please take this particular thing off this way to practice this kind of problem, especially this is what clear all of you. This is clear. Okay. So let us now try to solve one previous year JEE Mains problem based on 7 investments. So this is the problem. So this is my problem that we need to solve for. Let us say, so please try to read the and try to answer this. Okay, try to answer this problem. Again, very simple, yet effective question. Okay, please read the problem carefully and try to do the lines. Read the line. And once you do that particular line, you will see we automatically find the way and you can okay, plus minor rest. Okay, please try to solve this. Please try. So if that is the problem, please say what is that. If the line which are given as two lines with parameter s and the velocity such that they are two clear, right? So if we have two clear lines, then the shortest distance of two clear lines is also equal to zero, right? Because if the lines together under their line, the solution is okay. So what we mean by covalent lines is that it is interesting the concept of three lines to that two lines. So in this case, the lines will either intersect or either be parallel. So if we have in this case, let us for in the equation of line is as follows, like this, is equal to 10 to the 10, right? And theta defined from the first line. Okay. And the equation of my second line will be obtained as follows. So it will be obtained as x by 1 equals to I minus 1 by 2 equals to z minus 2 equals to e upon. Now, this line, if they are covalent line, then I will do it and 50 for either line the parallel. So if this line is if this line is the result of m, if if this line is minus of 2, if these lines are not even parallel, then the minimum distance will be equal to 0. The shortest distance, okay, will be equal to 0. So if I try to solve for the minimum distance is by doing x1 minus x2, y1 minus y2, and z1 minus z, whatever we have studied, 1, 2, and 3. So if I solve for this particular equation 0, then I will obtain minus 1, 4, 1, 1, minus lambda, plus lambda, 1, 2, and 3. Sorry, minus 10. And this terminal in six. So what happened as well, we will again get lambda equals to minus. So what we obtain is that this particular cases two lines would be parallel, two thinner, only when lambda comes to be minus. This frequency is included. This three option. This is part clear. This is part clear. So with this, we finished our discussion on the straight line in space. So this basically completes our discussion on space and here we'll be also using this particular idea again to two questions in plane. Okay. So planes we will be discussing about how we guide the different equation plane and then we'll see that what are different concepts of plane and line. So we may update on plane and line there are questions for the main line. And with that, again, I will try to discuss about what is the three-dimensional equation sphere. Okay. So we will be discussing about sphere at the end, but not a very complete discussion of sphere. Right? So we will just do basic discussion. And with that, we'll be done with our discussion on our 3D geometry. Right? So once we're done with the discussion on this, again, we will be starting this discussion with the basic discussion but instead of the previous year they make an problem is basically fit. So what we know is that the question in reading is almost related to the so we try to combine these two circles together in our better and also it will make you please make sure that whenever you are studying this part, so please try to study this group form, studying better. So please take this particular point. Okay, and with this particular part, I will this session over here. And thank you so much for your wonderful attention and wish you